Welcome to Study Loop.
The rate of input energy for part A is written as a Q amount of energy in del T time is the rate of the input energy. Then we can write a Q, the energy required to raise the temperature is equal to mass times the specific heat times del T, that's a change in temperature. Then we can find the um, rate of the input energy will be equal to mc. So this doesn't look like a C, sorry. So mc times delta T, change in temperature, over a delta small t, or change in time, um, by plugging in the values, which is 0.250 kg, times the specific heat of water, which is a 4186, times the change in temperature, which is 80, divided by the time we have is a 105 seconds. This gives us the power, which is equal to 797 watts. 797 watts. 97 watts. In part B, we are asked to find the mass of evaporated water. After 15 seconds, water is at 100 degrees. 100 degrees. So Q amount heat is equal to mass times the latent heat of vaporization. And from here we can solve for M. M it will be equal to Q over L V. Then we can write a Q is power times delta T. So over latent heat of vaporization. Power we already found is 797 for remaining time, which is 15 seconds. 15 seconds over latent heat of vaporization for water is 2260. This gives us, by dividing these two numbers, 5.3 grams. End of the problem. Thank you for watching.